Today's math lesson is on systems of equations. We're using elimination, and this is our second lesson. As usual, we have a video guide to go along with our video. So if you haven't printed that off, go ahead and pause the video, print the video guide, and then come back. That way you can do the examples with me. So if you take a look at problem number 1, we have two equations. We have 2x plus 4y equals 18. And negative 2x plus 3y equals 18. Now this is very similar to the problems that we had before for elimination. You'll notice that neither equation is solved for y, okay, so substitution is not the best option here. They're both in standard form. And since they're both in standard form, elimination's our best choice. Now remember, to eliminate a variable, you must have the same letter, the same number, but opposite signs. So looking at this problem, our first set of letters, the x's, we have the same letter, we have the same number, but the signs are also the same. These will not cancel when you add them together. Negative 2 plus negative 2 is negative 4, so that won't cancel. So if we check our y's to see if they'll cancel, we have a positive 4y and a positive 3y. Well, the letters are the same, but the numbers are not. And the numbers have to be the same for us to even have a chance of getting them to cancel. But if I add these together, I'm going to get 7y, not 0. So neither letter in this case is going to cancel. So we have to think of a different way of solving this. So the only problem that we have here in canceling out the x's is that the signs are the same. So what I need to do is find a way to change the sign of one of the equations, okay, either one. That way my x's will cancel out, okay? And what I'm actually going to do is multiply this whole equation by something, all right? Something that keeps this as a 2x but changes the sign, all right? So if I multiply this equation by just 1 times negative 2x is going to keep it negative 2x. It's going to keep it 4y. It's going to keep it 18. None of the numbers will change. The problem is none of these signs will change either. All right, but if I make this a negative 1, all of a sudden negative 1 times negative 2x, I'll still have 2x, but it will be positive. So if I multiply by negative 1, it will change the sign but keep my number the same, which is exactly what I want. I don't want to change the number, I only want to change the sign. So I actually multiply this entire equation by negative 1. Now, just so that you understand how this works, let's look at a very basic equation. 3 plus 2 equals 5. This is an equation. It is a true equation because 3 plus 2 is 5. All right? I just want to show you how this multiplication works. So if I multiply this entire equation by negative 1, each term multiplies by negative 1. Negative 1 times 3 is negative 3. Negative 1 times 2 is negative 2. So I have negative 3 plus negative 2 equals negative 1 times 5 is negative 5. Negative 3 plus negative 2 is negative 5. So as long as I multiply the entire equation by that negative 1, it's still equal. It's still a true equation. So multiplying this entire equation by negative 1, I haven't changed anything. It's still a true equation, okay? So we're not changing the integrity of the equation. We're not making it so it's not true anymore, all right? As long as you multiply each term, make sure you multiply all 3 terms by that negative 1. If you miss even one of them, it's off. So if I missed the 2 on accident, but I had everything else, negative 3 plus 2 is a negative 1, not a negative 5. So it's not true anymore. So make sure you multiply all 3 of them. So that's how we're going to get around this little trick here, the fact that the letters are not different signs. So negative 1 times negative 2x gives me a positive 2x. I'm just going to rewrite this whole equation. Negative 1 times 4y is negative 4y equals negative 1 times 18 is negative 18. Okay? So now we're going to ignore that first equation. Pretend like it's not there. We're going to add these 2 equations together. Okay? Add the second 2 equations together. Negative 2x and positive 2x cancels. those are gone. That's what I wanted. I wanted to eliminate them. I've eliminated the x's now. 3y plus negative 4y is negative 1y equals 18 plus negative 18 is 0. And this I can solve for y. I just divide both sides by negative 1 to get y by itself, and I get y equals 0. Okay? So the only difference from our previous lesson on elimination to today's lesson is that first step, multiplying by negative 1, recognizing that the signs are not different and they won't cancel. So just multiply by that negative 1 and then the steps become exactly the same. So once you find out that y is 0, you plug that back into one of the original equations. So looking here, I would pick the second one. The numbers are a little smaller as far as 3 is smaller than 4. So I'm going to use the second one. I'm plugging in 0 for y. Please make sure you're plugging in the number for the correct letter. All right, if you plug it in for x, you're going to get the wrong answer. So I'm going to have negative 2x plus 3, but instead of y, I'm going to put 0 in its place. 0, okay? Equals 18, so everything else stays the same. And then I just solve this equation for x. So what I need to do is my multiplication first, 3 times 0. Well, I get negative 2x plus 3 times 0 is just 0, equals 18. Well, negative 2x plus 0, anytime you add 0 to anything, it just doesn't change. Like 7 plus 0 is still 7. So negative 2x plus 0 is still just negative 2x. So we're going to leave that as negative 2x equals 18. And then from there, I just need to cancel out the negative 2. This is multiplication. They're right next to each other. So I'm going to divide both sides by negative 2. I get x equals 18 divided by negative 2 is negative 9. So my answer, remember, our answers are actually the intersection point of these two lines, because I could graph these and find out where they intersect, but that would take a lot of time. There'd be fractions. It would get pretty messy. So it's easier just to do elimination. But because it's where they intersect, we write our answer as a point. The x coordinate always comes first. That's negative 9. And then the y coordinate. My y coordinate is 0, so 0. So our solution for number 1 is negative 9, 0. For problem number 2, our equations are negative 2x minus 7y equals 26 and negative 4x minus 7y equals 24. Now we need to take a look at both sets of letters and figure out which one would be the easiest for us to work with. For the x's, we have negative 2x and negative 4x. The letters are the same, but the numbers are different and the signs are the same. So even if I multiply by negative 1, these are not going to cancel. So I'm going to check the y's and see if those would be easier to work with. For the y's, we have the same letter, the same number, but the signs are also the same. However, because the numbers are the same, all I have to multiply by is negative 1 to change that sign and only multiply one of them. And then they'll actually cancel. So that's what I'm going to do. I'm going to multiply my first equation by negative 1. And remember, when you multiply this first equation, you must multiply all of it by negative 1. Each term, all three. So we're going to multiply each one of these by negative 1. So negative 1 times negative 2x is positive 2x. Negative 1 times negative 7y is positive 7y. And negative 1 times 26 is negative 26. Now I can add the two equations together and one of the letters will be eliminated. So if I add these, negative 4x plus 2x is negative 2x. Negative 7y and positive 7y, those cancel, which is exactly what I wanted. So those are gone. And this equals 24 plus negative 26. The signs are different, so I actually subtract those. 26 minus 24 is 2. And I keep the sign of the bigger number, so it's a negative 2. And then from here, to solve for x, I just have to divide by negative 2 on both sides. So negative 2 divided by negative 2, that's gone. And negative 2 divided by negative 2 is just 1. So x is equal to 1. But remember, we're not finished yet. We have x, but now I need to find y. So use one of the original problems, all right? In this case, I'm going to go ahead and use the second one because 24 is smaller than 26. It really doesn't matter, but I'm going to use the second one. So negative 4x minus 7y equals 24. I'm going to take out the x and put 1 in its place. So I'm going to have negative 4, parentheses, instead of x, I'm going to put 1, minus 7y equals 24. Remember, make sure you plug this in for x. It's x equals 1. Don't plug it in for y, you're going to get the wrong answer. So do your multiplication here first. Negative 4 times 1 is just negative 4, minus 7y equals 24. So to solve for y, I need to cancel out this negative 4. The opposite of negative 4 is positive 4, or adding 4 to both sides. So negative 4 plus 4, those cancel, that's 0. We get negative 7y equals 28. 24 plus 4 is 28. And then our last step is to just divide. So I need to divide both sides by negative 7. I get y equals 28 divided by negative 7 is negative 4. So I'm negative 4 here. My answer then, remember we always put the x-coordinate first. The x-coordinate is a positive 1, so that comes first. And then the y-coordinate is a negative 4, so negative 4. So my answer for number 2 is 1, negative 4. For problem number 3, our equations are negative 4x minus 4y equals 4, and negative 4x minus 7y equals negative 17. So we need to check our letters, see if anything's going to cancel right away. Otherwise, we need to figure out if we have to multiply by negative 1 or not. So taking a look at the x's, we have the same letter, so that's good. The same number, also good, but the signs are the same. Remember, we need the signs to be opposite for it to cancel. So I'm going to check the y's just to make sure, but it's looking like the x's are going to be the easiest to work with. Same letter, but different numbers for the y. That's not going to work for us. The x's are going to be easier for us to solve with, so I'm going to go for the x's. To change the sign, but not the number, remember we must multiply by negative 1. And just multiply one of the equations, but you must multiply the whole equation by negative 1. So negative 1 times negative 4x is positive 4x. Negative 1 times negative 4y is positive 4y equals negative 1 times 4 is negative 4. So at this point, we can go ahead and add the two equations together. My x's will cancel, which is exactly what I wanted. Negative 4 and positive 4 is 0, so those are gone. Negative 7y and positive 4y, when I add those together, I actually have to subtract because the signs are different. So I'm going to get 3y, and I must keep the sign of the bigger number. So it's going to be negative 3y. Equals, here, negative 17 and negative 4. The signs are the same, so I do add those. I get 21, and I keep the sign of the bigger number. So it's negative 21. From here, I just have to divide. So I'm going to divide both sides by my negative 3. So the negative 3's cancel. I get y equals negative 21 divided by negative 3 is positive 7. So that's half my answer, but I also need to find x. So to find x, go back to one of the originals. I'm going to go ahead and use the first one because 4, 4, and 4 is easier than 4, 7, 17. So I'll use the first one. I have to plug that 7 in for y this time, okay? It's y equals 7. So the 7 goes in for y. So my negative 4x stays the same, minus 4, but instead of y, I'm going to put 7 equals 4. So everything about that equation stayed the same except for y. I changed the y to a 7. And now I solve. Do your multiplication. So I have negative 4x. Negative 4 times 7 is negative 28 equals 4. So I still need to solve for x. My next step would be to cancel out the negative 28. So to cancel that, I'm going to add 28 to both sides. Negative 28 and positive 28, those cancel to be 0, so they're gone. I have negative 4x equals 4 plus 28 is 32. We have one last step. I have to cancel out the negative 4, so I need to divide both sides by a negative 4. Negative 4 divided by negative 4 cancels, because that's a positive 1. So I have x equals 32 divided by negative 4 is negative 8. So my solution, I'll put the negative 8 first, because you always put the x coordinate first. Remember, alphabetical order. So negative 8 and then 7. This is our solution, negative 8, 7 for problem number 3. At this time, go ahead and pause the video. Try number 4 on your own. It follows similar steps as the last 3 we've done together. And then pause the video, come back and check your work. For problem number 4, our equations were negative 3x minus 6y equals 18 and negative 2x minus 6y equals 8. I noticed that my y's had the same letter, same number, but the same sign. So I multiplied the first equation by negative 1, which gave me positive 3x plus 6y equals negative 18. And then I was able to cancel out the y's, okay, because they're opposites. So negative 2x plus 3x is 1x, which is the same thing as just x. And that equals 8 plus negative 18. The signs were different, so I subtracted. I got 10, and it's negative 10 because the 18 is bigger. So I found that x equals negative 10. I then took that negative 10 and plugged it into the second equation, okay? And I plugged it in for x. If it's x equals, the number must go in for x. So I have negative 2 times negative 10 minus 6y equals 8. I multiplied and got positive 20. I then subtracted 20 from both sides. So I got negative 6y equals negative 12, kept the sign of the bigger number. And then I divided both sides by negative 6 and got y as positive 2. So my solution, because the x term comes first, my solution is negative 10, 2. And that's the end of our lesson on systems of equations, and it's our second lesson.